We're here today to collect ash from Eyjafjallajökull, which you can see behind us. Of course, everyone will remember the giant eruption we had in April of 2010, and we're collecting the very ash that came out of that volcano so that we can do testing with a new instrument which will be able to detect the ash at some distance on an aircraft.
When the Eyjafjallajökull eruption took place in 2010, and that ash stayed in the atmosphere, was transported by plumes from Iceland across the ocean and in over Europe. And when you have that much ash in the atmosphere, the concentration of all the tiny little ash particles is high enough. It's a threat to aviation because it can have impact on the engines.
Most of the ash is actually glass particles. The important bit about that for aircraft is that the glass actually can melt if it gets into a jet engine.
The VOID system, Airborne Volcanic Object Imaging Detector, is an instrument that is able to detect the ash at perhaps distance of 100 kilometres or so. We've collected ash of the kind that came over to Europe and caused all the disruption, and so that's the stuff that we're going to take back now to Toulouse and then put into the atmosphere and use our instrument to detect it. We'll have one aircraft which will sprinkle the ash into the atmosphere. We'll have another aircraft which will come at it from a distance with our instrument mounted on board and see the cloud in situ in the atmosphere.
This is a fairly unique experiment. Nobody's done this before, and we're really excited about giving this a go, and it's the guys from Airbus who need to be commended. They're the ones who came up with the idea, and we support their efforts.
If the sensor works, it could participate in better describing and circumscribing the contamination in a volcanic ash event.
I've been working on this for about 20 years. It would be great to see that finally something working on aircraft in the future and making flying safer and economic again.